All right, here we go, geometry folks. We got a couple of new ideas here we're going to take a look at in a little bit of detail, and then we're going to do one quick proof of one of these theorems, and then on to some proof practice. We'll do a couple of practices today on this video, and then you'll have one assigned to you to have done before class. So, without further ado, we start with the no choice theorem, and this is a theorem that really is telling us, well, of course, we have no choice. But we do have to have a specific theorem for it, and it's called the no-choice theorem. It says that if two angles of one triangle are congruent to two angles of a second triangle, so in this case, angle A is congruent to angle D, angle B is congruent to angle E, well, then there's no choice. The third angles must be congruent. Or in this case, angle C must be congruent to angle F. Now, three congruent angles does not tell you your triangles are congruent, because I can come up with an infinite number of triangles that are, say, all 60-degree angles. They'd not have congruent sides, so congruent triangles have to have congruent sides and angles. Three angles is not enough. We've learned so far the postulates of side, side, side congruence. If all three sides are congruent, that is enough. We've learned angle, side, angle. So if two angles and the included side are congruent, that is enough. And we've learned side, angle, side, two sides and the included angle. That's enough. The next one we need to learn is called angle, angle, side congruence. And this states that if two angles and a non-included side, two angles, non-included side are congruent, then the triangles are congruent. So in this particular diagram, we have that angle D is congruent to angle M. That's given through the marks on the diagram. We have segment ED congruent to segment NM, given as marked on the diagram. And we have angle F is congruent to angle O, also given as marked on the diagram. These three pieces of information allow me to conclude my triangles are congruent by angle, angle, side congruence. Why not angle, side, angle? Here's my side that is congruent, and my angles are not both touching said side. This is angle, angle, side, when my angles are not connected by my side. If I had segment DF congruent to segment MO, that would be angle, side, angle. It does matter. You have to be very specific which theorem or postulate you are using to prove these are congruent. All right, before we get some proof practice with that, let's take a look real quick at the no choice theorem proof. So in this case, we know that angle A as given is congruent to angle C as given. How can we prove this? Well, angle A is congruent to angle C was given. The next thing is what we have to assume from our diagram. I have vertical angles, and my vertical angles are congruent. So I state that they're vertical angles because I assume it from the diagram, then they are congruent because vertical angles are congruent. Now that's enough to state that angle B must be congruent to angle D, and that is the no choice theorem. I can just write no choice theorem. Okay. And you can see, I always say don't trust the diagram, and it's true, but it's obvious in that diagram, the sides aren't congruent, my triangles aren't congruent, just those angles. All right, let's take a look at the next page here. Again, I don't have the diagram, so I'll draw that for you here in a moment. And there it is. So, given angle H is congruent to angle M, given that segment HM bisects segment GK, that means GK is the one that's getting cut in half. So the conclusion here is that segment GJ is congruent to segment JK. So I have two congruences right now. I need three before I can make my triangles congruent. And these should say triangle. HGJ and triangle MKJ, not angle. We're not quite ready for that yet. And that's going to be my vertical angles here. So that's something that we can assume to be congruent. I'm going to put numbers in my diagram. I'm going to allow that. If you guys are wanting to do that instead of naming it, that's okay. But you still have to assume that they're vertical angles. So my proof is going to look something like this. All right, so the angles are congruent given. My bisect statement is given. The conclusion from the bisect statement was that segment GJ was congruent to segment JK. The reason is the bisect implies two congruent segments. I state that my angles are vertical angles. I cannot use angle 1 and 2 if I have not labeled them in my diagram. Because I've labeled them, I can use it. Now my angles are congruent. Now my triangles are congruent. Make sure they are named accurately. H corresponds to M, G corresponds to K, and J corresponds to J. And that is angle, angle, side. Because I have two angles, angle H and then angle 1, and a non-included side corresponding to two angles, angle M and angle 2, with a non-included side. Angle, angle, side congruence. If that's still a little confusing, maybe go back and rewatch that proof again. Listen to me talking through that problem one more time. Okay. We're going to do one more practice here. And it might look a little bit more confusing. I'm going to let you guys pause this and see what you can come up with first. After you pause, I might have it set up as a flow proof at the bottom, and then you can pause again and try to write it as a two-column proof. All right, so let's take a minute here. There's a lot that's going to go into this proof. All right, so we take a look here. I have my highlighted triangles are what I'm trying to prove are congruent. The only thing that I have marked that's a corresponding part of those triangles right now is segment DM congruent to segment KN. I have to somehow come up with other parts of this triangle, these triangles. There's a handful of ways I could go about this. I could somehow find segment MN congruent to segment DK. They're not marked congruent. This is 3 tick marks, this is 1. But because of my statements down here and because PN is congruent to DT, I can use the division property to make that statement. That's going to get me 2 sides. I also see that they share a side. I could get all 3 sides and use side, side, side here. The other thing that I have in here is my congruent angles, but they're not part of my triangle yet. But I could do congruent complements. I could do subtraction property. And we had a proof similar to this on one of our previous quizzes. So and then I could use side angle side. There's a couple of different ways to do this proof. Okay, I'm going to do this one using side angle side and not use the reflexive property, just so we can see and have access to a different type of proof. And I'm going to show you in a moment here how I would write this as a flow proof. Then we'll translate that into a 2-column proof. All right, so here's a flow proof. A little hard to follow when I haven't written through it, but I actually worked this backwards. I started with my congruent triangles, and I knew I needed 3 congruent statements to get my triangles congruent. According to my diagram that we had up there, I knew the one given was that segment KN was congruent to segment DM. That can go anywhere in here, but I put it in the middle, and I knew I had other reasons here. Okay. Now, I then had to look back and see what else was true. Well, we talked about how segment NM was going to be congruent to segment DK through the division property. What am I dividing? Well, I had the given of my congruent segments PN and DT combined with my 2 midpoint statements. these segments, N, M, and DK, are now divisors of congruent segments. That's the division property. One that's a little trickier now is my subtraction property. I had to actually back up quite a bit. My angles, DMK, and should maybe not be DMK, but MDP. That's a better correction here. It's angle MDK and angle KNM are congruent because I had my right angles that were congruent. I had to state they were right angles, which came from my given. Notice I just backed all the way up to my given of perpendicular. Both perpendiculars told me right angles told me congruent. Okay. Now that my right angles are congruent, I can subtract my smaller congruent angles. Two congruent angles are giving me a subtraction congruency. Okay, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 steps in this 2-column proof. If you haven't written it yet, try it now. And then here would be my 2-column proof. 13 whole steps. I tried to color code it so you could see where everything came from. The 7th step or statement is my first angle congruence. And so I had a few of my givens there. Everything in blue led me to that congruence. Then I had to go back and take a few more givens and get my segments congruent. Then I had the 1 congruent segment. I have my 3 congruent segments. 7, 11, and 12 are the 3 segments or the 3 statements that allow me to prove my triangle is congruent. 2 of them are sides, 1 is an angle. The angle is included, it's side angle side. I like to highlight these or circle my statements that allow me to make my triangles congruent. That way I know I have made all 3 of my congruent statements. In a flow proof, I know that I need these 3 congruences before I ever make triangles congruent. So this is kind of a 2-column proof, my way of doing that. I have some students who on their triangle congruent row, they'll go into the reason and they'll leave these 3 blanks, and then they'll write down the statement that allowed them to make this conclusion. So statement 7, 11, and 12 allow them to make that. None of that is required. It's all just really important that you know you need 3 congruent statements, parts of your triangle, before you can state that your triangles are congruent. All right, so there is going to be 1 practice proof I want you guys to work on before class. Try it. If you're wrong, you're wrong. No harm, no foul, but we'll get some good practice and good discussion based on that.